In question 3, we have to complete the electronic configuration for a copper atom and a copper ion. So in a copper atom, when you check the periodic table for copper, just 29 are there. So when you complete the configuration, it will be 1s. First, when you write the configuration, you write in terms of the energy. So it will be 1s2, but overall configuration should be in terms of orbital, like in the position 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, because copper is like 29. So when we arrange, it should be 3d9. But actually what happened, remember, for a copper, like this is in terms of the energy, first electron will occupy the lower energy level first and then it will move to higher. But in case of a copper, what will happen, because when half-filled orbitals are there, half-filled orbitals are more stable as compared to partially filled orbitals. So one of the electron jump from S to D. So as a result, it will become 4s1 and it will become 3d10 to gain the stability, because when S is having one electron, that is half filled, it's stable, and D is having 10 electron, it is full filled, it's also stable. But when we write the configuration, we write in terms of the order. So we will have 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. No, we always write the configuration for remember, always for chromium and for copper, you always write like the configuration how they are stable. Okay, so it's actually the electron, it's that's how the copper is existing. So remember, for copper and chromium, so try to learn the configuration, not learn, just try to practice the configuration for the first 30 elements. But as the question, till argon, it is same. So what is the atomic number? We don't have to write this whole, because already they mentioned argon is there. Like argon is what it is, 2, 8, and 18. So till 18 electron, it is already there. So we don't have to put this all. We just have to write the 3D and the 4s. So till argon, it is there. So what I will write? I will write 3D 10 and I will write 4s1. Because this till here is the configuration of argon. So instead of writing this all, we can say this is still argon. And then when it loses two electron always lost from the last shell. So first it will lose electron from 4s and then it will lose electron from 3d. So the left will be 3d 9. That's how we write the configuration. A sample of a copper contain isotopes copper 63 and 65. The proton number, you will use a periodic table. So 29 will be there for both. Then a neutron number you will subtract. So this will be 34 and this will be 36. And because there is no charge on them, so both will be 29. Explain the term isotope using the information in the table. So the term isotope means they have the same number of the proton but different number of neutron. That's how we define the term isotope. State why two isotopes of a copper have the same chemical properties. The chemical properties depends on the number of electron in the last shell. So you will say because the two isotopes have the same number of electrons in the last shell or the same electronic configuration. That's why they have the same chemical properties. The relative atomic mass of a relative atomic mass of a copper in this sample is 63.4. Calculate the percentage abundance of 63 and 65. So if I say the abundance of 63 is X, what will be the abundance of 65? So it will be 100 minus X, because the total abundance, like total percentage, will be 100. So if I say 63 is X, then 65 will be 100 minus X. Like if I say this was 23, like 25%, So this will be 75%. So how we work out is 100 minus 25, 75. So if one is X, the other one will be 100 minus X. So average mass of the isotope, which is 63.4, is equals to percentage of the isotope. It is X multiplied by its mass, 63, plus the percentage of the isotope, which is 100 minus X multiplied by its mass, 65, divided by 100. Then we just have to simplify this equation, a mathematical equation. 100 is divided, other side multiplied. So 63.4 multiplied by 100. This will be 63x. This will be 6,500 minus 65x. And then 63.4 times 100, and this 63x minus, so this will be minus 2x. So this will be divided. So just mathematical equation is there. Solve for the value of x. After getting the value of x, so what is the value of x? That will be the percentage of 63, and 100 minus x, that will be the percentage of 65. X is 80. The value of x when you solve this, yeah, x is 80. That's right. So x is 80, so 63 is 80% and 65 is 20%. Copper sulfate can be made by reacting solid copper to carbonate with dilute sulfuric acid. Write an equation for this reaction, and state symbols are not required. So when a copper carbonate, a metal carbonate, copper 2 carbonate is reacting with sulfuric acid, it will result in a formation of a salt, copper sulfate, copper 2 sulfate, plus carbon dioxide plus water, H2O. The equation is, I think it's balanced, so we don't have to balance this equation. Then how to work out the water of crystallization? An experiment was carried out to produce a pure dry crystals of hydrated copper sulfate. Copper 2 carbonate was mixed with a 50 cm cube of 1 mole per dm cube sulfuric acid until no more react. The mass of a copper sulfate was obtained was 10.87 gram. Calculate the percentage yield of this reaction and give your answer to appropriate number of the significant figure. So we have the equation. When a copper carbonate was reacting with the sulfuric acid, it was giving copper sulfate plus water plus carbon dioxide. The volume is there and the concentration is there, so we can work out the moles of a sulfuric acid. And after working out the moles of the sulfuric acid, we can work out the moles of the copper sulfate, because we need a percentage yield. Like we want the theoretical value. So concentration times the volume will get the moles. So this will be 0.05. Okay. So 0.05. And the ratio between sulfuric acid and copper sulfate is 1:1. So we'll get the same moles of the copper sulfate. And we'll find what mass we should get. So we multiply by the molar mass. Molar mass of a copper sulfate, copper is 64, sulfur is 32, and oxygen is 16 multiplied by 4. So when you multiply 60, what's the answer here? The molar mass of hydrated is there. So I have to use a hydrated one. Now what we have to do, we have to take, because this produces a copper sulfate, but this copper sulfate is converted into hydrated copper sulfate, like CuSO4 reacted with 5 water molecules to form CuSO4.5H2O. So we got the moles of copper sulfate. From moles of a copper sulfate, we'll find the moles of hydrated copper sulfate. So the ratio is 1 is to 1 between them as well, because 1 mole of anhydrous copper sulfate will give us 1 mole of hydrated copper sulfate. So if we were having 0.05 moles of copper sulfate, we'll get the same moles of hydrated copper sulfate. Then we need the mass of hydrated copper sulfate. The molar mass is 249.56. So it will be multiplied by 249.6. So when you multiply them, that will give us what mass we will get. That is 12.48. That is the theoretical mass. Practically, when it is done, you're getting 10.87 grams of hydrated copper sulfate, but theory suggests you should get 12.48. So what is the percentage yield? The percentage yield is a practical value. So practically, we got 10.87. Theoretically, we should get 12.48 multiplied by 100. So this will give us the yield of this reaction, which is about 87%. Is it clear? So from moles of sulfuric acid, we got the moles of anhydrous copper sulfate. From moles of anhydrous copper sulfate, we got the moles of hydrated copper sulfate. And multiply by the molar mass to get the mass in gram of a hydrated copper sulfate. So this was a pop quiz related to this week.